Okay, welcome to our brand new unit on Pythagorean relationships, chapter 3 in your textbook. So we're talking here about squares and square roots. So I want to do a little bit of definitions, right? So there's a lot of words that are very, very similar. So hopefully at this that you can look back on for clarification later. So the first one, the product of a number by itself is called a square. Okay, so what that means, let's see, a product, remember that's multiplying, right, of a number by itself. So, for example, this would be 3 times 3. So the product is the answer, right, of this question. So we would say that 9 is the square of 3. Okay, so when we multiply a number by itself, we say that we're squaring the number. And you may have heard that before, right? We're squaring a number. Right, if you square 4, right, 4 to the exponent 2, you get 16. So since 3 times 3 is the same as 3 squared, which is 9, the number 3 is called the square root of 9. Right? Root means, like, roots are in the ground, right? In the ground of a tree. So you're going down, right, into the bottom. Roots are usually small, right, smaller than the 9. To the source, right? To the source of the tree, you're getting to the root. So we write that as 9, and then your calculator, well, that little funny, it's like a check mark with a little hat on it, right? So we can say that the square root of 9 is 3, right? Or the square of 3 is 9, right? Or we're squaring 3 to get 9. So you see what I get, right? They're all really similar. So blank is a whole number greater than 1. Okay, so this is a little bit different, something, but we need to talk about it. A prime number is a whole number. The whole numbers, right, mean no decimals. Okay, and here it says that it's greater than 1. Right, so that means it doesn't equal 1. A prime number is not equal to 1, but 2, 3, 4, 5, off you go. All positives, great, because they're bigger than 1, no decimals. Okay, so you got some examples for you over there, right? No decimals, and no zeros, and no negatives. So, got that terminology behind us. Let's look at the right here. So, a perfect square for a whole number is, so it could be something like, well, 1 times 1 is 1. 1's a perfect square. Right, or 2 times 2 is 4, right? 4 is the perfect square. 3 times 3 is 9. Those are the perfect squares, right? So 1, 4, 9, 16, 25, right? Off we go. So in words, any whole number that can be expressed is a square of another whole number. Okay. So let's look at this question here. It says, what's the area of a square that has a side length of 10? So if this is my square, right, and remember that squares have sides that are all the same length, right? If the length here is 10 centimeters, I want to find the area. So maybe you remember this, right? Area of a square, or any rectangle, is length times width. And a square is just a special rectangle where all the sides are equal. So we can say x squared, or side squared. So in this case, right, our side is 10. So 10 squared, 10 times 10 is 100. So we'd say the area is 100 centimeters squared. Okay, nice and easy. This question, what's the square root of 100? Now, you're trying to look for two numbers multiplied by itself to give you 100. Right, so this might jump out at you. If you don't know, remember you can always hit this button on your calculator. Sometimes you have to hit the number first and then the button. Other times you hit the button, then the number. So every calculator is a bit different. So you got to get used to it. So the answer to this, guess what, is 10. Interesting. All right? 10, 10, 100, 100 seem to be related. So why don't you pause the video here? Got a couple questions, right? Some just basic evaluation. You just want to put in the number, right? Square root of 49, 7, easy enough. Right down here, what's the area of a square with a side length of 4? Right? Remember, area is x squared or side squared. right? So this one would be 4 squared. Make sure you've got your units, centimeters squared. What is the square of 11? So we've got to come back up here, right? 9 is the square. So that means that you're going 11 times 11 to figure out the square of 11. And then the last 2 questions on the front, what's the side length of these 2 squares? Okay, so this one you're working backwards. Like you already have the area. We know that area is side squared or x squared. So if area is 64, right, I'm trying to find the letter part. Well, this is kind of cool. If I want to get rid of that exponent, right, in our last unit we talked about Sam, Deb, right, we're at the exponents change. If you want to get rid of that exponent, guess what you do? You take the square root of each side. Pretty cool, right? And what happens is square root of 64 is 8. So that's your answer. You might kind of work backwards and be like, okay, well, that's 8, then that's 8, right? And figure it out. But like I said, pause the video here and finish up the rest of the questions on the front. All right, welcome to the back. Now this one is kind of fun. It says, in this list of whole numbers, circle the numbers that are perfect squares. So you might need to, on the side, go 1 times 1 is 1, right? 2 times 2 is 4. 3 times 3 is 9. And you're looking for these numbers. So when I scan here, right, 5 times 5 is 25. 8 times 8 is 64. 10 times 10 is 100. The other ones, right, aren't two exactly the same. 6 times 4 is 12, but it's not the same number. So it's not a perfect square. So this big empty space below is for you to do some factor trees. Now you may or may not remember this, so we'll go through a couple together. So determine all the factors by determining the factor pairs. The product, right, answer to a multiplication question, of a factor pair is equal to the number. All right, lots of jargon. What they want you to do is to take the number 24 and determine the factors. So factors are 2 numbers that multiply to give an answer, right? A particular number that you're looking after or you're looking for. So any 2 numbers. Now someone else might say 2 times 12. Someone could say 6 by 4. Let's go 2 times 12, right? You'll both get the same answer in the end. Now, prime factor is where you're going to stop. It's called a prime factor tree. So let's maybe put that word in there, prime. So you're going to stop when you get to all prime numbers. Now we know 2 is a prime number, right? We're going to stop. So there's nothing else we can multiply to get 2. But 3 times 4 gives me 12. Right? 2 is prime, so I'm going to leave it there. 3 is prime. Hey, 4, 2 times 2. Once you get to a bottom line that is all prime numbers, you're done. So if you were to punch this in your calculator, 2 times 3 times 2 times 4, you'd get to 24. Okay? Now let's do the 25 one. So 25, right, is 5 times 5. Guess what? Prime number. So I'm done. That was nice and short. Okay? So go through and do the other 4 that are remaining. There's a couple really good discussion questions at the end here. Right? So this one says, which number have an even number of factors? So we went back to here. 24 and 25 both have even numbers, right? They have 2. This is 4. Right? They have even number of factors. Which one has odd numbers of factors, right? So you have to wait and see. What do you notice about the factors of perfect squares? Right? So remember, 25 is a perfect square. 24 is not. Right? So you have to look to see if you, after you do the rest, if there's some sort of trend happening there. And then how could you determine if a number is a square root if you only had that bottom row? Right? See if there's a pattern. Okay, and that's your rest of your homework tonight. You can check the following day for the answer key. Okay, good luck.